In previous video, we have discussed the topic electrostatic. Basically, electrostatic is the study of charge at rest, and the charge is a physical property of matter, just like mass. Charge is responsible for electrostatic force, where mass is responsible for gravitational force. Both forces are depend on distance, and both forces are inversely proportional to the square of distance between them. Gravitational force is always attractive in nature, where electrostatic force can be attractive or repulsive depend upon the nature of the charge. Gravitational force does not depend upon the medium, means the force acting on to body is not vary, means it is equal in air and it is equal in water and anything else. The force does not depend upon the medium, where electrostatic force depend upon the medium. So the force acting of two charges is vary from medium to medium. It is something in air, then another where you get another value from if you change the medium. Gravitational force is very weak compared to electrostatic force. The charge. There are two type of charges. First one is positive and second one is negative. And we have also discussed the quantization of charge, which is stated that charge of a charged body, any body, is equal to the integer multiple of a smallest charge, which is charge of an electron, that is q, that is the net charge of a body, is equal to n, where n is an integer number, maybe it is 0 1 2 3 4, and e is the charge of electron, that is 1.6 into 10 the power minus 19 coulomb. And the force acting between two charges is directly proportional to the product of their product of their charges, and inversely proportional to the square of distance between them. Now here k is a constant whose value is 9 into 10 the power 9 Newton meter square per coulomb square, and it is equal to 1 by 4 pi epsilon naught. Epsilon naught is permittivity of free space. Let's take there is a charge q1 and there is another charge q2, and both are positive charge in nature, and the distance between them is r, and we know that from Coulomb's law the force acting between them is repulsive in nature because they are in they are in same nature, means they are like charges, so the force will be repulsive in nature, and the force is directly proportional to the product of their masses and inversely proportional to the square of distance between them. So we have to introduce a new constant, that is k, and k is depends on medium, means the force acting between two charges can be vary from air to water and water to material solid. So this force is not constant means the if let's suppose q1 and q2 it is in free space, then force is F, and if the charges kept into water, then F will be changed because K depends on the medium. The value of K is 1 by 4 pi epsilon naught, and this epsilon naught is permittivity of free spaces, and the permittivity depends upon the medium. The value of this constant is 9 into 10 to the power 9 Newton meter square per Coulomb square. So the Coulomb's law is 1 by 4 epsilon naught q1 q2 by r square. This is the magnitude of force that acting between two charges. Okay, now we know that the force is a vector quantity, so we need a direction to describe it. So now we are going to discuss Coulomb's law in vector form. Similarly, we are assume that there is a charge q1. Here charge is q2. Both are positive in nature, and this is a coordinate system, 2D. Let's say it is xy plane. Here is the position vector. Position vector is nothing but it describes its position. Means if it is a 2D coordinate system, it is on a 2D coordinate system, then our position vector will be equal to the magnitude of the x direction, particle travel in x direction, and the its direction plus y travel in y and its direction, and this is known as unit vector. And we know that the vector full vector is equal to magnitude and its direction, and this direction is known as unit vector because it is only direction having a unit magnitude. Now we are going to study the force. So q1 experience a repulsive force due to q2, so the force is toward this direction. Let's say F12. Here F12 means F12. F12 means force on Q1 due to Q2. And the displacement vector will be in this direction. Because force is in this direction, so displacement vector will be in this direction. And if you have basic knowledge of vector, how to add them, so head of any vector we have to connect to tail of another vector, and the odd one will give us the resultant vector. So here head of R2 is connecting to R, and the odd one means R1 is the resultant. So it is R1, it is R2, and it is R. This means R2 plus R will give us R1, triangle law of vector. So R will equal to R1 minus R2. Okay. Remember this equation? Now the magnitude of the magnitude of the force will be a constant product of their charges square of distance between them. This is the only magnitude. And now, as we know that a full vector means vector is equal to magnitude and unit vector. So it is the magnitude, then unit vector will be this. As we know that r is r1 minus r2, then unit vector of r will be unit vector of r1 minus r2. F2 will equal to, okay, we should clean this. Now here F12 equal to K R1 Q1 Q2. Here magnitude, this is the magnitude of R, and we know that R1 is R is R1 minus R2, so the magnitude of R will equal to R1 minus R2 square, and unit vector will equal to the R1 minus R2, and this is the vector form of Coulomb's law. And we can do one further step, that is here. Look, a full vector is equal to its magnitude into its unit vector. Then a unit vector will equal to a full vector by its magnitude. So here R unit vector of R is equal to full vector by its magnitude, and this will give you full vector R1 minus R2 by magnitude of R. Putting this equation here, we get F2 equal to K Q1 Q2, and this will multiply with this, then it's become Q, and this become R1 minus R2, and this is the vector form of Coulomb's law. And now again, the force experience Q2 due to Q1 is F12, and the direction of displacement vector is toward Q2, then R will become as R2 minus R1. So force on Q2 due to Q1 will equal to K Q1 Q2 by R2 minus R1 cube and R2 minus R1, and this is the Coulomb's law in vector form. So this is the Coulomb's law in vector form. Now this question says that there are two identical poles. When identical spheres are brought in contact, then after separation they carry equal charges. Okay, now let's say the charge of each metallic sphere content Q charge. This will give the Coulomb's force will equal to K Q another Q by R square, then it will give you K Q square by R square. As we know that K is equal to 9 into 10 to the power minus 9 Newton meter square per Coulomb square, and the radius of the R will given as 0.5 meter, and the force is acting between them is 0.108 Newton. Okay, then this will equal to 1 point here. Putting this value in equation, let's take equation 1, then we have the force acting between them is 0.108 Newton, and the value of this one is K is 9 into 10 to the power minus 9. Value of Q we don't know, we have to find out, and this will give 50 is 0.5 square. Then Q square will equal to, okay, this Q square will equal to 0.108 into 50 square, and by 9 into 10 to the power minus 9. So this will give you around okay, let me calculate it. This will give you around 108, okay, into 0.50 square by 9 into 10 to the power 9, and this will give us here, look at this will give us 3 into 10 to the power minus 12, and let's take its square root, then it will be equal to 1.73 into 10 to the power minus 6 coulombs. So it is 1.73 2 microcoulomb. So each sphere has this much of charge.